Hi, my name is CJ Hissel, and this is my presentation on an automotive industry regulated by the Environmental Protection Agency. Now, I guess a little bit of background and interest into why I chose the data is just that I have this huge passion for the automotive industry. Ever since I was a little kid, I've always been working on vehicles, always just working around some sort of truck, car, or even something larger than that, such as a boat. So I've just always kind of had this passion for it. And I also found that there was a lot of general data for vehicles in the United States that was widely made public by the EPA in the US. And I guess a couple questions that I had for myself was what impact do these automobiles have on our greenhouse gas emissions? And also, what impact does the EPA have with laws and regulations within the automotive industry? Now, I began my data collection by first going to data.gov and really just searching for a couple keywords, including automobile and emissions, and kind of just parse through each of the data sets to figure out if any of them matched my interests and what I really wanted this whole project to, the direction for it to head towards. My original data set actually consisted of pretty much all the makes and models from the year 1984 up until 2021, and the data included factors such as miles per gallon, total tailpipe CO2 emissions, as well as a couple of other statistics such as fuel type, who the actual manufacturer was, in what country that they came from. And I decided to compare this data set with a data set from the United States Census that had what percent of the United States population lived within cities. And I also found on the Energy Information Administration website it was a data set that involved our total emissions for all fuel types within the United States. Now, my data collection consisted of three different methods. The first one was using the Pandas Read CSV module, which was used to parse the CSV file from data.gov that essentially contained all of the vehicle information that I spoke about earlier. The second method was by using web parsing and the request.get module with Beautiful Soup and its HTML scraping capabilities, where I gathered the census data for city populations and percentage of the United States population that lived within urban areas. And finally, my last method was to use the request.get as well as the JSON module to import JSON dictionaries from the EIA website, which was where I gathered all of the emissions data for our total output for emissions for all fuels. Now, the data cleaning consisted of dropping unnecessary columns from the extremely large vehicle data set, which, as I stated earlier, had a couple extra and excess categories, including just kind of the manufacturer, what country it came from. And as well as that, I used the renaming of columns and to make it easier for access later on. So for example, some of the columns were named City 08, and I renamed them to their proper form, which is something like City MPG. I also created a couple new columns, including the difference between Highway MPG and City MPG, as well as did a couple of quotient uh, devices where I took the quotient between engine size and tailpipe CO2 emissions, and those are just a couple new columns that I created along with a few others. I also converted the JSON string type into float as they are all imported as strings and needed to be turned into numbers for something especially important as the MPG values. And lastly, I dropped rows that contained information that was not relevant to the study that I was performing. So, for example, there was Tesla and a couple other electric vehicles, and they obviously had tailpipe CO2 emissions of zero and would just skew my data heavily in the wrong direction. Now, a couple of the data or the analysis that I found from my data was the MPG values for 1984 to 2021 models isn't something that is not linear. This is shown on the right-hand side of this presentation, where we actually see almost a dip between 1984 and around 2008. And I actually ran a normal test indicating that the p-value was under 0.05 and that this data was not in fact linear, which was extremely surprising to me. I thought that the data was going to be linear, trending upwards in miles per gallon values, but this was not the case. It was actually not until 2009 to 2021 where you can see this upward trend occur. And as part of my study, I actually compared this to a couple laws that were passed, including the Energy Independence and Security Act, which was passed or in 2007, and it actually mandated heavy MPG regulations for all vehicle types in the United States. And that's right around this area. You can see right in 2007 is where this downward trend kind of stops and it begins to pick up um, in an upwards direction, which was largely caused by this Security Act in 2007. Now, moving on to tailpipe CO2 emissions, we actually see the same chart here that I had plotted, and we are referring to the purple and the actual right-hand side y-axis, which is displaying tailpipe CO2 emissions for 1984 to 2021. Again, I ran a normal p-test, and to my surprise, I actually found that this data was also not linear, but it had a very similar trend to the miles per gallon data in that the trend was actually extremely flat up until 2007 when the bill was passed, and we see that tailpipe CO2 emissions for all vehicles actually begins to trend downward extremely fast. So we go from about 500 grams per mile of CO2 being emitted on average for each of our vehicles, all the way down to right around 400, which is the direction that the Security Act actually was looking to pass or to have results with. Next, we move on to total emissions, which came from the EIA website. And here we are comparing the similar chart. So the blue line is actually what we had just seen on the previous slide in purple, with total tailpipe CO2, or I guess average tailpipe CO2 for all automobiles. And on the in the red side, which is now switched to the y-axis on the right side, we see this is all fuel emissions that are emitted for all types of transportation, so airplanes, um, trains, automobiles, but this is in million metric tons. And some trends that we do see is that a decreased tailpipe emission had in 2007 had a pretty much small impact on the overall greenhouse emissions that were in the United States. And it's very surprising to see this because on the previous slide I stated there was a 20% decrease I guess, from 2007 to 2020, which makes up about 59% of all transportation related emissions. But this only attributed to 6% in the total change from the years 2007 to 2008, which is this big dip right here, something that's pretty surprising. Um, Now, another statistic that I found very interesting was in the percentage of population living in cities for the United States actually was steadily increasing from 1970 to 2010. And the beginning of this trend did not initially result in increased city miles per gallon values, which I thought it would. Um, but in fact, there was a decrease in MPG values during this time, and then slowly, once the 2007 Act was passed, that's when we see the MPG. So there was a very large shift in this population, and actually a 7% increase going from 1980 to 2010. And our last data analysis comes from just kind of something fun that I wanted to do. It was really just comparing engine types to see if there's any differences. And diesel engines came out to be on top for everything, or every category for miles per gallon, as well as tailpipe CO2 emissions. They had the lowest or the highest miles per gallon ratings and the lowest tailpipe CO2 values across the board for all years that I had tested these. So in conclusion, the EPA regulation did in fact have an impact on both environment and the automotive industry. However, the CO2 impact on the environment that these regulations has had is simply just not enough. These emissions continue to steadily increase, and although the automotive industry has been hit hard with getting these numbers down, they still are not doing enough to really emphasize this point was the graph with millions of pounds of CO2 being emitted. It's continuing to trend upward. Um, and then a little bit of some conclusions that I found that were extremely fun and were more geared towards my love for automotive industry was that a larger engine size did not necessarily mean poor gas mileage. It's a testament to how great these engineers have become in this recent years. And overall, I think this is a great analysis and it was very interesting.